So now we've come to the last bit of the meeting, and here to give a summary of today's proceedings is Mahesh Anand. Please.
Thank you, Mr. Chairman, and thank you all the organizers for inviting me. And I think when I was asked to do the summary at the end, my obvious question was that the format of the meeting looks so broad and so diverse. How am I going to make a real-time presentation if everybody is speaking? And in fact, that's what I tried to do, but I miserably failed. So, but Jo was very kind that she said, oh, don't worry about, summarizing everybody's talk. You give your own thought. I said, that's great. But I'm not going to give a talk. I mean, this just is a slide that I will explain to you why I have chosen this. Because I'm a sample scientist, so I work on moon rocks, Apollo samples, and therefore my summary would be slightly biased towards that. And it has been a fascinating day. What amazes me as a lunar scientist, that most of the time I'm busy with thinking about what science question can I solve. But everywhere I go, whether it's a conversation in an airplane, and I just came back from Washington yesterday after attending a 3-day NASA workshop about water on the moon. And we haven't talked much about that in this meeting today. But that's a topic that has recently brought back lunar exploration into limelight. And not just that, you go anywhere, moon always crops up. Well, it does crop up in the sky, but it also crops up in conversations. And it is amazing, and I was so excited to hear about this workshop because that's what it is trying to do. And somebody asked the question that how do we as scientists and engineers actually engage with public? Well, this is one of the ways you do it, because you don't just have to engage with the public, you also engage with people who are not necessarily planetary scientists, who also need to come along with you. Okay? So I think this workshop has been great, and it has achieved many of its objectives, I believe. And before I forget or I get cut out at the end, I thought I must thank the supporters who have provided financial support or any other support for this successful meeting. And I asked Jo, and she confirmed that the Royal Astronomical Society, the British Society for History of Science, and in particular, somebody who is very generous and who is a physics alumnus of this college, has enabled this workshop. So thanks to all those individuals and organizations. This would not have been possible without them. Let's get going with the summary though. So why this slide? I just want to highlight that we shouldn't look at the moon in isolation. It's not just about the moon. And I think sometimes as scientists we get quite pigeonholed. And that is something which I'm finding that you also develop some kind of a reputation that when you go, oh, Mr. So-and-so, Mr. Moon or Mr. Mars is here. It shouldn't be like that. Moon is a planetary object. You have to put what we know about the moon, the history of the moon, the science of the moon into context. And the context is the solar system as we understand today. And hopefully, whatever you have heard today has convinced you that moon has an important role to play in our quest to understand our own solar system and then go beyond to then start understanding the exoplanets and then go beyond that. So that was the purpose of this slide, although this was a slide of my other talk. So what did we hear this morning? I mean, Carolyn gave a fantastic overview of how moon has played an important role in almost any religion you can take, almost any culture you can take, any country, anywhere in the world. Moon has been there, and it has been very important. It has been with us all throughout. Well, our understanding of the moon has all been changing, and it is going to change as we learn more. But it has played a very important role in our society, cultural, and religious context. And I thought that Carolyn actually almost summed up the whole meeting by saying it towards the end that this is like a destination for humans. And you heard in the last talk that, there are plans to go to the moon, to stay there for extended periods of time. That's not an end in itself, but that's to achieve bigger and better things beyond that. Then we came to this. I mean, this is really, even I had not seen that video, you know, the libration. So even I learned something new today from this point of view. And I did find the NASA video that was referred to, which I hope I can pull up if you see, which somebody says the phases should be seen. You can see the phases here. And this is the Goddard Space Flight Center that put together this video. It's not coming up for some reason. It's on my screen. Never mind. Let's not worry about technology just yet. We then heard about tides. I mean, this is something that has been known, you know, from historical times. But just to see the clarity and the resolution with which now we are able to actually look at these tides, the effect of them, and to predict them is wonderful. So again, the influence of the moon on the Earth. And you can take it from there. You can say, okay, what about the influence of the moon on humanity? I know books have been written about it. But you can go beyond that and say, okay, what about the origin and the evolution of life itself? Does the Earth have life? The advanced life, because it has its moon that has helped somehow to stabilize the climate, the obliquity, etc. You know, there are many people who are interested in that aspect of understanding the history of Earth and the moon. So moon is not just telling us about itself, moon is not just telling us about the rest of the solar system. It seems like it has an important role to play. So yeah, coming back to it, you know, the tides have had important role to play throughout, and they still play a dominant role. And we touched upon this thing of supermoon, you know, a few days ago. And believe me, the day it was supermoon, I landed in Washington, and the immigration officer asked me, so what do you do? I said, I do this. He said, have you seen the supermoon out there? I said, really? Okay, so you are also aware that there is supermoon. This picture was taken with the Soyuz rocket in front that was ready to launch 3 astronauts to the International Space Station. And I think the previous speaker mentioned we have our French astronaut. Are they docking? Yeah, Thomas Pascal, tonight they are docking. But what I also found out that it also has the oldest person who has ever been to space or has spent the most number of hours. I can't remember her name, but she is a US astronaut, has clocked 400 or 500 days in space. Amazing. But this Soyuz rocket was ready to launch on the eve of supermoon. And on the left-hand side, I just wanted to, on my right there, what I wanted to highlight is what Ian Crawford tried to capture in his talk as to what has been the legacy of the Apollo program. I mean, there aren't enough hours in a day to actually summarize that, to be honest with you, because it's not just about producing people who are lunar scientists or lunar engineers. I think we can argue that Apollo program in itself has been one of the best examples of how you foster innovation, how you foster, you know, how you motivate people and train not just one generation, several generations of scientists and engineers and teachers and you know, citizens. So I think we mustn't forget that. And the value of that kind of program cannot be calculated in terms of dollars. And when we ask questions about, oh, are we not better off spending that money elsewhere? If I had enough time, I can convince you that every dollar you spend, probably you get 10 back. Not immediately, but down the road. So we shouldn't be forgetting that. And at the end, I think if we can use exploration as, or it could be also, you know, anything like solving world's problem with regards to diseases, illnesses, anything that we want to take a good cause, we can use those as a common purpose so that the entire globe can put a combined effort to solve those problems. So there can be a peaceful environment, not the environment of friction and war and whatnot. So I want to highlight and go a little bit further into what happened after the Apollo program and why the moon has apparently come back into more common knowledge. And the reason being that we have been to the moon, we did some field work there, and as Ian pointed out, we only did the field work in a very restricted region. But more importantly, we brought back some samples, and we did bring back 382 kilograms. More than 250 kilograms are still remaining. But we are one of those lucky ones who still get allocated these Apollo samples. But our technology has improved so much in the past 45 years that my predecessors, who needed 1 gram of material to do an analysis, I'm now doing it using 1 microgram. Okay? So those days, they probably were losing that as dust while just managing those samples. And here I'm working on a single dust particle to tease out the information. That gives you the value of sample return. That when you have samples from another planetary body, how much information you can derive and for how long. And this is where my point about training several generations go. I wasn't born when the Apollo missions happened. But I'm standing here talking about them and actually working on the same samples that those astronauts were collecting. Right? So that's just fantastic. You heard about some of the leading theories that actually came about the origin of the moon, the violent giant impact theory. It's not just about the moon. It actually tells us about the planetary accretion processes. In this case, it's applicable to Earth-Moon system. But this is our basis, as I said, to expand our knowledge about the accretion processes that are happening in the rest of the solar system or beyond. We can't get there yet. Much of this information was derived based on sample studies. If we didn't have those samples, we wouldn't be talking about this. Yeah? I'm an isotope geochemist, but I don't want to bore you with. But the only thing I'll tell you that there is a whole suite of information on different isotope systems that is forcing us in this direction to think that the moon had a very violent birth. And its genesis is intimately related to the genesis of the Earth. It's not a foreign object, but it's also not something that has just spun out of the Earth. And if you want to talk more about it, come to dinner and I'll be happy to talk to you about that. One of the things that we learned from it is another thing called lunar magma ocean, which is what happened in the aftermath of this giant collision. When the moon formed, it was so hot, it became a big ocean of magma, which later on cooled and formed the moon. How do we know this? Again, teasing out information from the lunar samples. However, that's fine. It's a hot collision event. We think that nothing survived. But what happened? 8 years ago, there was an orbiter that India sent, its very first lunar orbiter called Chandrayaan 1. And these are fantastic times because this is not just a time where the United States is, against the USSR. There's a global surge in space exploration. You have India, you've got China, you've got Korea planning now a lunar mission. Japan already did their lunar mission recently. Even some Gulf states are planning to go to the moon. Yeah? So there is a real interest in space exploration. And this Indian mission had many instruments from different countries because they realized that they can't solve everything on their own. This is their first attempt, so they better get help from everybody. So they were very clever in that way, and they said to NASA, do you want to send a few instruments? They said, yeah. So NASA sent an instrument on Chandrayaan 1 called Moon Mineralogy Mapper. And 3 M's stand for M cube. And what it was simply looking at the reflectance of the lunar surface under different wavelengths. And what they found was totally a big game changer. And this paper came out in 2010 where actually they showed this, they colored it, but what they're showing is what their near-infrared spectrometer is measuring, which corresponds to the presence of very thin layer of hydroxyl which is OH, as you know. But we call it, colloquially, we also call it water, because you can combine 2 OH to produce water and a bit of hydrogen, etc. So whenever I'm going to say water, from now on, I either mean hydrogen, or hydroxyl, or molecular water. But not much molecular water, mostly hydroxyl. Everything together is termed water. So the announcement was made that, oh, there is a thin layer of water on the moon. And alongside, there was another mission that NASA sent by themselves, which is still operating. Ian mentioned this, the Lunar Reconnaissance Orbiter, LRO. That is an orbiter that is still imaging the moon, but it carried a small spacecraft with it called L-Cross. And what it did was it had a spent rocket on it, which it crashed into a lunar polar region. Why the lunar polar region? Because for many decades there has been talks, speculation that there was radar data, there was other remote sensing data suggesting that there might be blocks of water ice at these lunar poles. So there are only 2 ways of confirming that. Either you land something there on top of this, ice, or you crash something into it so that the ice becomes water vapor and the plume gets up, and the orbiter that is going around it is going to sense it with different instruments. And that's what they did, because it's much easier to crash something in the moon than to have a controlled landing for a different period of time. So this was the second piece of evidence that proved that actually there was some water, most likely water ice, at the lunar pole, about 5 to 8%. Might not seem much, but actually if you take a soil and you add 5% water into it and take it to temperature at minus 150 degrees centigrade, it is harder than a concrete, and it becomes saturated. You can't add any more water than that. So that was the second thing that was confirmed. Alongside, that was the time when actually I was coming into the field, and I thought, I was mostly interested in age dating these rocks. So saying, okay, you heard 3 billion year, 4 billion, that was my job, to find out how old these rocks were. But when we heard about the possibility of water on the moon, some of us thought, why not to look into the lunar samples? It's 46 years on, we have better technology than what we had before. It may be that people tried to find it, but they just didn't have the sensitivity to do that. And that's exactly what we found out. We looked at some of the polished chips of some of these rocks that you see there. These are, so this one is Apollo 15 rock. This is another Apollo 15. And what we do is we make a polished section, and those of you who have done geology would recognize this is a microscope image, that we started looking for minerals that might contain hydroxyl in their mineral structure. And lo and behold, we found a mineral called apatite. So much of our work about the water inside the moon has come from our investigation, focusing on this mineral apatite and some of those volcanic glasses that you heard in Ian's talk that came through fire fountaining. Yeah? The evidence was already there. In order to have fire fountaining event, you need volatiles. So the whole assumption that the moon was volatile poor or had no water is not correct. It's our problem to explain how they got there. But we can't say it doesn't have it because that's the data. The data tells us that actually we do have volatiles and water on the moon. Now let's try to figure out, based on the evidence we have, whether it's isotopic, whether it is, your numerical modeling, or whatever it is, you have to explain the data. And so this is what we did. So earlier this summer, we published a paper in Nature Communication where we tried to use the present constraints that is present in the community based on the sample analysis, how much water there could be in the moon. And we calculated how that could have been brought to the moon, at what stage, and what could have been the ultimate source. And it seems like you can explain all this relatively easily by assuming or demonstrating that actually these meteorites called Carbonaceouschondrites, if you have heard of them, which are quite rich in water and other organics, they were the one that delivered water to the Earth-Moon system. And also to answer another question that was raised before was when the Earth got its water, certainly not at the time of the moon formation. The giant impact took place within 40 million years of the solar system formation. And there is absolutely no evidence that there was free-flowing water on the Earth's surface. Okay? So the Earth and the moon received water much, much later. Anyway, that's the history of water as we understand it today. It's a very fast-moving field. And last 3 days I spent with 40 other colleagues discussing about this. And at the end, we all agreed that we don't understand anything about this, so we need to understand. And that's not just me. It's okay, I can understand that I don't understand it, but 39 other colleagues from NASA and other places, they say same thing. That means there is more to do. So that means we need to go back. We need to go back for a variety of reasons. You already heard, technological reasons, to go to Mars, to test the technology, etc. And European Space Agency has a plan. In the near term, we are hoping in 2 weeks' time we will hear something more about it. That will guide our future planning. But then there are a few other concepts. So whether Europe is going or not, Russia is going, China is going, India is going. So it does not matter. I'm not so worried about it because ultimately I want to understand more about the solar system. How we get there is not that important. On the right-hand side, you see something of a very new concept. There was a mission that was floated called Lunar Mission 1, which was going to be publicly funded mission. Unfortunately, not enough money was raised for this, so the mission has been de-scoped at the moment. And right now, the team is focusing on using moon as an educational resource. And I think that goes to a question that somebody else asked, how do you take a school to the moon? This is exactly what this particular project is trying to do, but because this is a first private initiative to go to the moon, it is not having plain sailing. And it only raised $1 million, whereas the ambitious mission that it had, it required several hundred millions of dollars. So it might still happen in 10 or 20 years' time, but in the interim, we are focusing on engaging children at school. And you heard about the Moon Village, so I'm not going to dwell on it, but there's enough to say that there are various activities ongoing that makes it more realistic than it looks in picture, to tell you the truth. And I think I have got only 1 or 2 extra slides. Am I out of time already?
Pretty much.
Pretty much, yeah. Okay. So, just like this workshop, we also have a reasonable lunar science community in this country, which operates under the node of NASA called Solar System Exploration Virtual Institute, SURVEY. And we have about, 100 members. So, you will notice that actually there is a lot of lunar science research going on in this country, but you would be surprised if you start looking at the journal papers that come out and the conferences that we organize and things. So this has been great. I mean, here we have more than 100 people interested in the moon who never came to those kind of workshops. And we have a few hundred other people who come to other workshops. So that means that there is significant amount of interest. We just need to, be more networked. And I think I should finish in here. So I don't want to take any more of your time, but there is also a free MOOC course that we do at the Open University that anybody can take on. And it's not just about the moon, it's called Moon's MOOC. So you not only learn about our own moon, but you also learn about the rest of the moons in the solar system. So if you're interested in it, go to the Open University website and you can find out. Moon's MOOC?
Yeah. Oh, okay, thank you.
Yeah, okay. And with that, I hope I've not forgotten to say anything. Just want to say thank you all once again, and thank you to the organizers for giving me this opportunity to summarize the meeting in my way. So, thank you.